Okay, so in this video, we're going to be talking about permutations and combinations. In fact, section 2 deals strictly with permutations, and then section 3 deals strictly with combinations. And traditionally, we teach both of these at the same time, so I'm going to be teaching you two sections at the same time. All right? Now, the first thing is it's always good to start off with just a really basic example of what we were talking about here because we're going to need a brand new math tool, something that you may have seen or maybe you've never seen it before. But here's an example right here. There are 5 places to eat in town. We want to eat at a different diner each day until we tried them all once. The question becomes, how many different pathways can we take to eat at each diner once? Okay? So if you think about the fundamental counting or the fundamental principle of counting, we know we have 5 options. So 1, 2, 3, 4, and 5. So we'll call this diner 1, diner 2, diner 3, diner 4, and diner 5. All right? So the idea behind this is on the first day, we have 5 options. We can choose from any one of the 5 restaurants that we want. So day 1, we have 5 different restaurants. Now, on day 2, we know we can no longer go to the one that we went to previous day. All right? So let's say we went to Wendy's. Well, Wendy's is out now. Can't go there. So how many options do we have left? Well, we have 4 options. Now, on day 3, we have 3 options left, and then 2 options, and finally, the last restaurant. So whenever you are multiplying a number in descending order like this, where we have 5 times 4 times 3 times 2 times 1, which is 120 ways, by the way, we call this right here a factorial. And factorials have a very special symbol. That symbol looks like this. It is the number with the exclamation point to the right of it. That is, we read this 5 factorial. And all that means is we're going to take 5 times 4 times 3 times 2 times 1. So it just goes right down the list. So, for example, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial is just 3 times 2 times 1. So now you know what a factorial is. In fact, your calculator probably has a factorial button. If you have the TI-84, like I know I do, so let me go ahead and zoom out here. If you look on the far left-hand side, you're going to see a button that says math, okay? Click on the word math, and then you have these different options. You have the math option, you have numbers, you have complex numbers, and then you have PRB. And the PRB stands for probability. So we're going to scroll over, And if you look down here at option number 4, there's your factorial button right there. So, for example, 5 factorial. Oops, sorry, wrong button. 5. Go over to here. 5 factorial is 120. 8 factorial is 40,320. So you can see factorials get very big very fast. And that's because you're multiplying these numbers together. So now that we know what a factorial is, something else special happened in this problem as well. The first thing was the factorial notation. That's the first thing that happened. The second thing is the fact that, let me erase this real fast. The second thing was we provided a restriction. What we said was, and if you remember, the restriction was we want to eat at each diner only once. Now, that means order matters. All right? So if I go to Wendy's on the first night, I cannot go to Wendy's again. Or if we go to Chick-fil-A on night number 2, you cannot go there again. It's over. You got to go to a different restaurant now. All right? So anytime order matters, we call that a permutation. So when order matters, that is called a permutation. All right? So order matters, no repeating objects. All right? They scream permutation. All right? So let's think about another very straightforward example. There are 9 baseball players in a batting lineup. How many different lineups can the team have? All right, so if you think about this, order matters. Here's a situation where if you bat first, you can't bat 5th as well. So when you're reading these problems, all right, you have to ask yourself, always ask yourself, does order matter? Okay? So in this situation, order totally matters. So for the first batting position, you have a total of 9 players. For the second batting position, you have a total of 8 players now because you used one. For the third, you have a total of 7 players left over because you used 2 of them already. And I think you can see that once again, we have our factorial here. So what is 9 factorial? Well, I don't know. Let's find out. I'm going to grab my calculator, though I know that much. All right, so let's turn it on. 9 factorial. 362,880. So that's a lot of different lineups you can have with just 9 players. Okay? So, something was happening in these 2 examples. Like I said, first, we learned about this factorial notation. And second, we learned about does order matter? And if it does, that's called a permutation. All right? There may be some situations, all right, where you have a group of items, but you're only selecting, let's say, 3 of them. So there are, let's say, 8 people applying for 3 jobs, right, or job positions. And the positions are senior level, junior level, and entry level. Senior level pays $85,000. Junior level pays $60,000, and entry level pays $35,000. So clearly, there's an order here. I mean, let's be honest. All right, if you were applying for this job, you'd want the senior level position because it makes the most. All right. So in this situation, order totally matters. But here's the catch. You are not selecting everybody. You're only selecting 3 people, and 8 people applied. So how many different ways can we select 3 people? Okay? Well, to help us calculate this, all right, we're going to use what we call a permutation, or the permutation formula. All right? So the permutation formula looks like this. All right? So let me write it, and then I will explain it. All right, so here's our formula. This is nothing more than the number of possible permutations if our items are taken. So N is going to equal the total items available. All right, in this case, in our problem, N is going to equal 8 because we have 8 people. R is going to stand for the items chosen. All right. So for us, R is going to be equal to 3 because we're only picking 3 of them. All right. So the way that this formula works is basically wherever you see the letter N, you put an 8. Wherever you see the letter R, you're going to put a 3. So it's 8 permutation 3 is equal to 8 factorial divided by the quantity of 8 minus 3 factorial. Now from here, we could simplify this a little bit. In the numerator, we have 8 factorial. In our denominator, 8 minus 3 is 5 factorial. Okay? Now, from here, you have 2 ways that you can do this. You can either A, do it by hand, or B, use your calculator. Either way is fine with me. I'm going to do it both ways so you can see it. First, let's do it by hand. I know 8 factorial is 8 times 7 times 6 times 5, and it keeps going down all the way to the number 1. But watch what I do. I'm going to stop at 5 factorial. And the reason why I stopped at 5 factorial is because my denominator is also 5 factorial, which means when I go to simplify this, the factorials will cancel themselves out. They reduce themselves. 5 factorial over 5 factorial is going to reduce itself. Therefore, I'm only left with 8 times 7 times 6. And when you take 8 times 7 times 6, you get 336. All right? So that's how we do this by hand. The other way is to go ahead and use your calculator. So let me show you that. So here's our calculator here, and let me turn it on. Let me get the detached screen so you can see it. I'm going to put it right here in the middle. All right, so the other way is use your calculator, like I said. You could do 8 factorial divided by 5 factorial. And notice, you're still going to get 336, which is what we want. But some of you may be sitting there going, well, wait a minute, floater. When you hit the math button and you went over to PRB, option number 2 is that NPR thing. And yes, you are correct. So, depending upon the version of calculator you have, all right, you just got to figure out how to type it in. For the one that I have, I can go directly to NPR. Oops. I'm going to hit 8. Go over to the NPR. And then hit 5. Because notice on the left-hand side is the letter N, so that's the 8. On the right-hand side is the letter R, so that's going to be 5. And all I got to do is hit enter, and I get the wrong answer. So I must have typed something in incorrectly. So let me find my mistake. And all of you should be yelling at me because it's not 8 permutation 5. It's 8 permutation 3. I looked at the wrong number by accident. And there's our 336 right there. So sorry for my mistake, but now you know why I have comments turned off, because if I make a mistake, then the people in the comments section of all YouTube videos basically eviscerate you for making a simple mistake. So that's why I don't have comments on. And hopefully you're sitting there laughing or chuckling, because that's what ends up happening. I made one mistake once and I had somebody rip me apart. So I was like, all right, fine. Game over. No more comments for you. So that was it. But anyways, so that is how we use the permutation button on our calculator. The most important thing, does order matter? Because if order matters, that is going to be a permutation. All right? But that kind of begs the question, what if order doesn't matter? If order doesn't matter, we call this a combination then. All right? So here is this is going to be section 3 now, if you're following along in your text. All right? So if order doesn't matter, we call that a combination. And yes, the combination also has its own formula, and it's very similar. It's NCR, which is equal to n factorial over the quantity of n minus r factorial, and then you multiply it by that then you multiply by the r factorial again in your denominator. Be very careful. All right? Because this entire thing is in your denominator. All right? Too many times do I have students that use their calculator and they end up typing it in incorrectly. So be careful. The entire denominator is n minus r factorial times r factorial. So here's an example here. And it's going to be very similar to the one we just did. Just notice how the wording changes. There are 3 positions open at XYZ company. 8 people applied. How many groups of 3 can we create? So notice here, although the situation is the exact same in terms of the number of positions and the number of people applying, there is no order because the positions are all the same. Order doesn't matter here. So this would be a combination. So order, doesn't matter. All right. So once again, we're going to let n equal 8 and r equal 3. So we get 8 combination 3, which is equal to 8 factorial over 8 minus 3 factorial times 3 factorial. Now, let's simplify this a little bit. 8 factorial over, 8 minus 3 is 5. So you have 8 factorial in the numerator divided by 5 factorial times 3 factorial. Now, if you're doing this by hand, you can save yourself a little bit of the headache by understanding how factorials work. Notice in the numerator, I stopped at 5 factorial because I have 5 factorial in my denominator, and I know that these factorials will reduce. So that leaves me with 8 times 7 times 6 all over 3 factorial, which is 3 times 2 times 1. However, 3 times 2 times 1 in your denominator is 6. So that reduces all of them. So the answer is 56. So I realize this was a lot of like simplifying, okay? That's why it's always nice to have a calculator, all right? So I'm going to show you how to do this on a calculator as well. So here's our trusty TI-84 again. Where am I looking? There we go. Nope, didn't want that. All right. Now, once again, there is a combination button on the calculator. So we're going to do 8, hit the math button, go over to probability, and we're going to choose NCR. So it's 8, NCR 3, we hit enter, and we get 56 again, which is exactly what we should have gotten. So when order doesn't matter, you actually get less groups. And that's because the order in which these people will appear, we don't care. Which is a really nice little thing to remember. Permutations will always be greater than combinations. So that's kind of like a nice little way to remember, like if you're comparing your answers, the number of permutations should always be larger than the number of combinations. And that's because permutation order matters. A, B, C is not the same thing as B, A, C. Those are two different things. However, in a combination, A, B, C is the same exact thing as B, A, C because we don't care about the order. So the last thing that I'm going to talk about is what if we have repeated objects? Okay? So like, for example, and this is like the most boring, you always find this in every single textbook. How many ways can we rearrange the letters in the word Mississippi. Okay? So there's a very special formula for this, which is n factorial over, and then the way that it's written is like this. All right. Now, I know this looks crazy, all right? But it's basically the total number of objects goes into the numerator. So we have a total of 11 letters up inside the word Mississippi. Now, in the denominator, you put the repeated items. So, for example, N1 is going to be the number of, or better yet, I'll just write it like this. N1 will be the letter S. So how many letter S's do we have? Well, we have 4 of them. So that would be 4 factorial. And then the next item is going to be the next repeated item. So that's going to be the letter I. So we have 1, 2, 3, 4 I's. So that's 4 factorial. And finally, we have the last repeated object, which is going to be the letter P. And that's going to be 2 factorial. So to put this into our calculator, I'm going to show you how to do this. You have to remember, this entire thing is in the numerator. So you got to maintain that it's in the, did I say numerator? The entire thing is in the denominator. Sorry for my misspoke. Once again, you know why I turn off comments. But anyways, we got to maintain that they're all in the denominator. So here's how you do that. It's actually a lot easier than you think. I'm going to turn on our calculator. All right, so here we go. So in my numerator, it's going to be 11 factorial. Divided by. Now, to make sure everything is in the denominator, all you have to do is put it in parentheses. So parenthesis, 4 factorial times 4 factorial times 2 factorial. And then end your parenthesis and hit enter. So there are 34,650 ways that I could rearrange the letters of Mississippi. And that's it. The most important part, putting this in parentheses when you use your calculator. And with that, sections 2 and 3 are done.